Okay, so now we're going to talk about Module 2, Lesson 2. This one's about simplifying expressions. So since we're working with expressions in this particular lesson, we're not going to see any equal signs, right? But before we start to be able to deal with more complicated equations, we need to be able to clean up expressions and make them into their simplest forms first. Okay, so we talked a little bit about like terms last time, so we'll start with just a quick review of that. If we have something like 3x plus negative 8x, and we want to put those together, these are like terms because the variable parts here are identical, right? So when we have terms that are like, we can put those things together, okay? And the rule's pretty easy. We're just going to add the coefficients in the front, so 3 plus I guess it's only easy if you remember your Module 1 stuff. We hopefully we didn't completely forget all that stuff at the end of the test. So, got to remember how to do our, put our coefficients together. So 3 plus negative 8 signs are different, so we're going to subtract. 8 minus 3 is 5, and then we're going to take the sign of the larger number. So since 8 is negative and larger, it's going to be a negative, and then we're just going to bring our variable part on down, okay? So this simplifies to negative 5x. We can have more going on in our expressions. 5y plus 9 minus 3y minus 12, for example. Okay? And what's important here when we're trying to clean this up is that we only put the like terms together, like 5y and 9. Those cannot be combined because those are not like terms. They have different variable parts. Like the 5y term has a y. The other term here is called a constant term. It doesn't have a variable at all. But these terms, the 5y and the minus 3, those are like. And the 9 and the minus 12 are like. They don't have to be right next to each other in the problem to be combined. They just have to be like in order to be combined. So we're going to start putting these things together. So 5y minus 3y, well, our rule is just add or subtract the numbers in the front. So 5 minus 3 is 2, and then leave the variable part the same, and I've combined those terms. And then positive 9 minus 12. Remember, if you want, you can always change this to plus a negative if you want. Some people find that easier to work with. So nothing wrong with that at all. And then we're going to combine these. You got a positive and a negative, so our signs are different. We're going to subtract. So 12 minus 9 is 3, and then we're going to take the sign of the larger one. And so we are done at this point. Don't try to put this 2y and this minus 3 together because they're not like terms. If our terms are not like, we're working with an expression like this, there's just nothing we can do. We have to leave them separate. Okay? Okay, so we know that when we put things, now when we're adding or subtracting, it's very important that we pay attention to whether our terms are like or not. That's not the case when you're multiplying. Like if you have something like this, 3 times negative 10x, for example, right? We know this is a multiplication because these things are right next to each other. 3 is right next to the parenthesis. Okay? We can multiply these. It's fine. You don't have to have like terms for multiplication, just for addition and subtraction. So if we were doing this, 3 times negative 10, my signs are different. Got to remember our Module 1 rules, right? Signs are different when we're multiplying. Our answer is going to be negative, and then 3 times 10 is 30. And then the x just kind of comes on down. So we can go ahead and work that out, okay? But we are going to ask you sometimes to do more complicated things with multiplication. We might have you multiply something times something that has multiple terms, like 2x minus 7, okay? And to deal with this, we have a property called the distributive property. We very, very often see this, and we just say we're going to distribute to get rid of that parenthesis. And what that says is we're just going to take this number out front, and we're going to multiply it kind of separately times each of my terms inside this parenthesis. So We're just going to kind of do it one at a time. 5 times 2x, and we will get 10x there. And then 5 times negative 7. I know when I multiply positive times a negative, I'm going to get a negative. And then 5 times 7 is 35. And you'll notice I can't go any further. I'm done when I'm finished distributing here because my terms are not like. Sometimes you'll be able to go a little bit further, right? You might have a couple of more steps to this, but when you get to this point where all of your terms are unlike, variable parts are different, you just can't do anything else. And this is your simplified expression. Okay? Now we're going to learn some strategies later for how to deal with equations, and we're going to be able to go all the way down to get a single number answer, but we don't have an equal sign here, so we don't have those options. So it's very important when you're dealing with equations not to go too far. Okay, let's look at some others. Again, these will get more complicated, so let's look at something like this. Just real quick introduction, something I wanted to mention. What if we have an x with no number in front of it? So we have something like this, and we want to simplify it. Okay, so the first thing to note is you can't put the x and the 5 together because that 5 is not like, but you can put these two terms together, right? So you've got to identify your like terms first. Okay, once you've got those figured out, we're going to start to put those things together. And here, we add the numbers in the front. This one doesn't have a number in the front that's written. It does have a coefficient, though. The implied coefficient on any variable that has no number in front of it is 1. So when we go to put these things together, we're going to add 1 plus 9 and get 10, and then we're just going to bring that x on down. And then we're also going to bring that 5 on down, and there's nothing we can do with it because it doesn't have any terms in this particular expression that are like with it. If our terms are not like, just got to bring it on down. Okay, so if you have a variable with nothing written in front of it, the implied coefficient in the front there is a 1. Okay, so let's take these ideas and kind of put them together and get something that's a little more complicated to work with. So let's say we have something like this. Okay, so quite a bit going on in this one, but when you're simplifying expressions, your first step is really to get rid of any parentheses that you have. Okay, now you'll notice here in the front, I've got a negative sign, but no number. Just like with the last example, the implied number here is a 1. Okay, and so our first step here is use that distributive property thing we talked about to get rid of these parentheses. So I'm going to take this negative 1, and I'm going to distribute it to each of the terms inside of my parentheses. So negative 1 times 5x here is negative 5x. And then negative 1 times negative 11 is going to make that positive 11. Okay? You'll notice when I had a negative sign in front here, all I really did was I changed all my signs. That's a pattern that you'll see pretty often. Works out just fine. Now this 3 over here, we're going to distribute that across to distribute to these terms inside this parenthesis. So 3 times 4x is 12x, and 3 times 6 is 18. So my first step here was to use the distributive property to get rid of all of those parentheses. I had a couple of sets of parentheses. I've dealt with those first. Next, I'm going to look for like terms, and I definitely have some. Negative 5x and 12x, those are like because they have the same variable parts, and 11 and 18, those are like because they're constant. So we can put those things together. So negative 5x plus 12x, got to remember my sign number rules, so signs are different. We're going to subtract those, so 12 minus 5 is 7. Take the sign of the larger one. Okay, and then 11 and 18, we can put those together. Okay, and we're done because our terms that we have left are not like. Okay, so a lot going on in that one. It kind of has all of the ideas from this lesson, so hopefully that makes sense. All right, so one last little idea. We talked a little bit about perimeter, okay? But sometimes you might have some variables in the terms of your perimeter. It doesn't change our approach, right? When we're doing perimeter for a shape like this, our rules say to add all the sides. So that's what we're going to do. I'm just going to kind of go around the sides. So 3y meters plus 7y meters plus another 3y meters plus 6 plus 6y meters over here plus 16 meters over here. But because we have some y terms and some constant terms, we have to really pay attention when we're putting these things together. All that we can do is combine our like terms, right? So these four terms here are like. We can put those together, and then these two terms here are like constants, and so we can put those together. So don't do too much. Don't try to combine things that are not like when you're adding, and we're definitely adding when we're doing the perimeter. So 3y plus 7y is 10y, plus another 3y is 13y, plus another 6y here is 19y. Okay, and then 6 and 16. We add those up and we get 22, and it's in meters because all we're doing is adding up all the sides, and so we're done, right? So when you have these terms, if they're like, you can combine them. If they're not like, you can't when we're doing this perimeter, so really pay attention to that in problems like this. Okay, so hopefully that's a good start for you on this lesson, but if you have any questions as you're working through it, please don't hesitate to let me know what I can do to help. Y'all have a good day.